All right, today we're going to work on this bonding activity. So you should have picked up this worksheet as you walked into class today. So what I'm going to do is I'm going to do number 1 with y'all and then also number 5 with y'all, and you are expected to do the rest on your own for the rest of class time. So for number 1, you basically have this giant grid. We've got all our elements, and it wants you to identify the different things about these elements. And so I'm going to do potassium with y'all, and I'm going to expect y'all to do nitrogen through sulfur on your own. So for number 1, we're going to look at potassium. It'll be handy if you've got your periodic table with you, so you can use either the one in your binder or the one right under your seat in class. So for potassium, for the chemical symbol, that's on your periodic table. So by now, we should know that potassium is K. And so we're going to go ahead and write down K for the chemical symbol of potassium. It also wants to know the total number of electrons. So if you look at your periodic table again, we're going to assume these are neutral atoms. So that means the protons will equal the number of electrons. So with potassium, potassium's number 19 on the periodic table. That number signifies how many protons it has. And so if it has 19 protons, we're going to go ahead and assume that it has 19 electrons. So I'm going to go ahead and write 19 right here. The next thing is we want number of valence electrons. So to refresh your memory, just in case you forgot since yesterday, when we look at the groups 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A, all of these represent the number of valence electrons each family has. And so this is only referring to the A group, not the B group. And so K is in group 1A, so we can say that it has 1 valence electron. So we're going to go ahead and write 1 right here where it says number of valence electrons. The next thing it wants is a Lewis dot diagram. These are atoms. So when we draw a Lewis dot diagram for an atom, basically all it wants is the symbol and dots representing number of valence electrons. So we have our symbol over here, so we're going to go ahead and write K. And then we have the number of valence electrons right here. So that's going to tell us how many dots we need to draw. And so in this case, I only need to draw 1 dot. And then finally, we have the oxidation number. So this may be the more challenging of all these little columns. But the oxidation number tells us how many electrons it'll gain or lose as it becomes an ion. And so looking at potassium, okay, we know that potassium has 1 valence electron. The ultimate goal is that we want it to follow the octet rule. So we want it to have 8. So it's actually easier for this to lose 1 electron versus gain 7 electrons to meet this octet rule. So we're going to go ahead and conclude that this will lose 1 electron. And so losing 1 electron, we're going to put a plus 1. And so this tells us that, hey, our element will lose 1 electron as it becomes an ion. So you're going to do basically all of these for nitrogen all the way through sulfur. Once you get done with this grid, you'll answer the questions at the bottom. And so it's going to ask you to draw and use some colors. So make sure you read the directions carefully. I'm going to go ahead and do number 5 with y'all. So flip it to the back side for me. And we'll do number 5 together. And so hopefully I'm not going too fast. But if I am, we can always pause and record this video. So that's a really great thing. Number 5, it says to find the tiles for Na and O. However, I don't have the tiles and the pom-poms that go, or the beads that go with this activity, so we're just going to have to rock and roll with it and just draw it out ourselves. So for number 5, it says find the tiles for Na and O. So I don't have those tiles, but you know that we are working with sodium and oxygen. It says to use red beads to represent Na's valence electrons. Instead of red beads, I'm just going to have you use a red marker or color pencils. So they should be at the front of the lab table. So you can go ahead and grab some once this video is over. And you're going to use purple beads to represent O. So in this case, again, I don't have purple beads, so you'll just grab a purple marker. It looks blue on this camera, but you're going to use a purple marker or color pencil or whatever I have up in the front, unless you have your own colors. And so we're going to use those colors to represent the valence electrons for each of those elements. As we continue reading, it says now demonstrate how Na and O form an ionic bond. All right, so we want to demonstrate how these two will come together and form an ionic bond. We're going to move the electrons to show what happens. And so we're going to go ahead and illustrate how that works. And so I'm going to go ahead and write this out. So I know I have Na and I know I have O, so go ahead and write that down on your paper as well. So an Na atom, you should be able to identify how many valence electrons it has. So looking at our periodic table, we can see that Na is in group 1A. So that tells us it has one valence electron. So what I'm going to do is I'm going to go ahead and grab a red marker. And if you don't have a marker right now, you can just go ahead and draw a dot for now, and you can get to this in a second. And I'm going to put one dot because I know Na has one valence electron. Oxygen, we know, has how many valence electrons? So looking at the periodic table, O is in group 6A. So we know it has 6 valence electrons. So what I'm going to do is I'm going to grab a purple marker, and I'm going to go ahead and draw 6 valence electrons. So 1, 2, 3, 4, 5, 6. So basically 2 of them should be paired up and 2 should be alone. And so I know that doesn't look purple on there, but it is a purple marker I'm using, so we'll just rock and roll with it, okay? And so just like what we did yesterday, our goal is we want to make sure these meet the octet rule. And so to meet the octet rule, we need to make sure that cations lose their electrons and anions will gain electrons. And so it makes sense that because this has 6 valence electrons, it's a lot closer to 8, so it would make more sense that our Na will give up its electron and give it to oxygen. All right, but even after Na gives up its electron to oxygen, oxygen now has how many valence electrons? It has 7 valence electrons, which is still not quite 8. So what we can actually do is we can actually throw in another Na. All right, so I'm going to throw in one more Na. I'm going to put a dot there because Na has 1 valence electron. And so by having 2 Nas, what we can do now is we can move this electron over here so that this one has a buddy as well. And so with 2 Nas, we're able to donate or give up 2 electrons so that now oxygen, instead of having 6 valence electrons, it now has 8, which allows it to follow the octet rule. Both Nas lose that outer electron, so underneath that is another shell of 8. So these also meet that octet rule. All right, and so just to draw on the side what that looks like, just in case we're still confused. Okay, Na looks something like this. And so we got 8, 9, 10, and 11. So it's got 1 valence electron on the outside. So this is the one we just moved. All right, and so when you get rid of that one, now underneath you've got that full 8 shell. So now 8, 8, and 8. We've done what we needed. That's pretty much it. Okay. And so when you're writing the chemical formula, this is where we use the crisscross method, all right? And so the crisscross method, we need to be able to write it as ions. So Na, if I write Na, we know that Na, so if we're just looking at one Na, it loses 1 electron. And so if it loses 1 electron, that's a positive charge. So Na plus, and if you want to put the 1 there, that helps too, but you don't have to. We know oxygen is going to gain 2 electrons. And so I'm going to go ahead and write O, and then I'm going to put -2. And so we know that these are the ions they form. So what we're going to go ahead and do is to find out the chemical formula, you can either refer to the picture or you can use the crisscross method to help write this chemical formula. And so remember, the crisscross method, we just take the numbers, not the charges, and we just crisscross them. And so 1 will go to O and 2 will go to N. And so what you have left is you have Na2O. And when you write the chemical formula, the metal always goes first, then the nonmetal. So Na is a metal, O is a nonmetal. So when I write this, it's Na2O. You do not write it as O Na2. That would be considered wrong. So make sure your metal is in the front. Compound name, we haven't gotten this far yet, so I'm going to go ahead and have you skip anything that says compound name because we haven't learned that quite yet. Once you finish all that, what you also need to do is you need to answer these questions. So when Na becomes an ion, okay, it gains or loses. We determined that it lost, because here we see that it lost 1 electron. So when I'm asking this, I'm referring to only one Na atom, not the entire picture, okay? And as it loses 1, it becomes a what? And we determined it becomes a positive ion. So make sure y'all are reading this carefully because there's a lot of answers that you can skip. there's a lot of questions that you may skip along the way, so read it carefully. The final thing that I forgot to mention is you also need to draw it as a compound, meaning you got to use the brackets and the Lewis dot ion structure. So Na, all right, we know it's a cation, so when we draw cations, you have to remember it's the symbol, the brackets, and the charge. And in this case, I've got two NAs, so I'm going to go ahead and draw two NAs. And then we got one oxygen. Our oxygen is our anion, so we're going to go ahead and write an O. Anions always have 8 dots, so when I draw the 8 dots, remember what we did last time? Of those 8 dots, how many are purple? We know that 6 of them are purple, so I'm going to go ahead and draw 6 purple dots. And then we know of those 8 dots, only 2 of them are red. And then finally, what I'm going to do is, because this is an anion, to draw the Lewis dot ion structure for an anion, you have the symbol, the dots, the brackets, and of course the charge, which is -2. And so to check your work to see if you did it right, all you got to do is pay attention to the formula and your picture. Do they match up? So in our chemical formula, it says that we have two NAs. In our picture, I've got 2 NAs. And in my formula, it says I have 1 O, and here I have 1 O. So this is good. So that means I've done this correctly. So you're going to do this for the rest of class time. Okay, you've got, let's see here, 1, 2, 3 more like this, and then you've got some questions at the bottom that you need to make sure you answer. You have until the end of class to complete this. When you're done, just make sure you turn it into the basket before you leave today. And then other than that, I hope you have a great weekend, and I hope to see you Monday.